Okay, so here we've got PCl₅, so that's like phosphorus pentachloride, and you can see it reacts with H₂O to form HCl and phosphoric acid, right? So we need to balance this. We've been asked to balance it, and we need to only use whole numbers in our final equation, right? So in terms of approaching the balancing process, the first thing I'm going to do is I'm going to work on auditing. Numerically speaking, we're going to work on auditing the occurrence of elements on both sides of the equation, both on the left hand side, the reactant side, and on the right hand side, so on the product side of the equation, right? So that's the first thing I'm going to do. So for shorthand, I'm going to simply write LHS for left hand side, and so we've got phosphorus, we've got chlorine, we've got hydrogen, we've got oxygen, right? So and similarly for the right hand side, right? So of course in our balanced equation we want these both sides to have an equal number of each corresponding to each of the elements. But let's look at what do we have currently, right? What do we have right now? So phosphorus only occurs in this species, the phosphorus pentachloride. So this is going to be 1, right? Cl, that occurs 5 times. Hydrogen, that occurs twice. Oxygen, that occurs 1 time. Now on this side of the equation, on the product side, for phosphorus, that occurs, as you can see, it occurs once. Cl, as you can see, that occurs once. Hydrogen, we've got 3 here and 1 here, so that's 4 times. And as far as oxygen goes, we've got O4, right? So that's 4. Right. So if we work our way down this list, what we can see is that phosphorus is well, it seems balanced, but the chlorine doesn't. We've got 5 chlorines on this side and only 1 on this side, right? And the hydrogen and the oxygen also is not balanced. I'm going to focus my attention first of all on the chlorine. We've got 5 times as much chlorine right now on the left hand side compared to the right hand side, and the only place where chlorine occurs on the right hand side is in the HCl, right? So what I'm going to do in order to try and get towards a balanced equation is I'm going to multiply the HCl by 5. So I'm going to use a coefficient of 5. I'm going to put that in front of the HCl. Okay, so that's going to effectively give us PCl₅ plus H₂O. No, that O is a bit too small. H₂O produces H₃PO₄ and 5, right? HCl. Okay. Now we've not changed anything on the left hand side. So because we haven't, when we do our auditing process again, it's going to be the same as what it was before. So left hand side, PCl₅ H₂O, it's going to be 1, 5, 2, 1, right? And on the right hand side, effectively if we take a look at this, the only thing that should be affected is the H and the Cl. For phosphorus, it's going to be the same as before. It's going to be 1, as you can see. You've only got occurs once, and there's no occurrence of oxygen in this species we did modify, so oxygen is also going to be the same. We're just going to have 4, right? But the HCl is going to be different, and hydrogen occurs in both species on the product side. So we've got 3 plus 5, so that's going to be 8, right? So for hydrogen, then for Cl, that's going to be 5, right? So as you can see, we have in a sense moved closer towards having a balanced equation, in the sense that we now have the same number of chlorines on both sides, but we still don't have the same, we have not balanced the hydrogens, we have not balanced the oxygens, right? But what you probably notice is that fortunately on the left hand side we have a H2O, right? And if you really consider what is missing in terms of trying to get things to a balanced point, if we divide the number of hydrogens on the right hand side by the number on the left hand side, so that would be 8 divided by 2, that would give us 4. If we divide the number of oxygens on the right hand side by the number of oxygens on the left hand side, that will also give us 4, right? And funnily enough, we have 2 hydrogens in the H2O and 1 oxygen in H2O, so which is all of our hydrogens and oxygens corresponding to the left hand side. So it would stand to reason that if we were to put a 4 in front of that H2O, our lack of having a balanced equation problem might be solved. So this is what I'm going to do. So if I do that now, I'm going to do PCl₅ plus 4 H2O, and then that's going to produce H₃PO₄ plus 5 HCl, right? Okay, so let's go through the auditing process again, right? So for the left hand side, we just modified this, so we do expect some changes. And that's if that doesn't look, that is a Cl. If it doesn't look like a Cl, yeah, I'm not convinced that looks enough like a Cl, so I'm just gonna, well, obviously in context it is obviously a Cl, but you know, I actually want it to look like one as well. So okay, there we go. Yeah, so for P, it's not going to change, right? We didn't put anything in front of that, so that's literally, as you can see, it's just 1. For the Cl, that doesn't change, it's still going to be 5. But for the hydrogen, we've multiplied our H2O by 4, which, so 4 times 2 is going to give us 8. And in terms of oxygen, that's going to be 4 times the O, which is effectively, we've got 1 O, so that's going to be 4. Okay. And you can kind of already see when you compare, right? You can see what we've just done here. And on the right hand side, we didn't change anything, so it's going to be the same figures as we just had calculated in the prior step. So PCl₅ H₄O. So that, you know, we're going to have 1, 5, 8, 4, right? And now if we compare the left hand side and the right hand side, what do we see? Well, what we find is that now we've got the same number of phosphorus, chlorine, hydrogen, oxygen, and the other thing is when we look at the coefficients on in the actual this final equation we've got here, we can see that all the coefficients are integer values, even the implied ones where the coefficient is 1, like in PCl₅ or H₃PO₄. Overall, we can see that all the coefficients are integer values, right? And so this is going to be our balanced equation, right? So if we go back to the top here, you can just kind of put that in here, that the balanced equation would be adding a 4 here and a 5 here, right? All right.